Welcome to the Margin Line. I'm Joe Lynch, head of go-to-market at Dandy. Today is special. For the first time, we're not filming in a studio. We're here in Provo, Utah, filming from our and the world's first ever fully automated digital dental lab. Behind us, we ship more than 250,000 restorations per month. This show is all about peeling back the layers of how technology is revolutionizing dentistry, especially in partnership with DSOs and ambitious private practices. We want to give you the inside scoop of what goes on in the lab, the challenges we face, the advances we're making, and the stories from the front lines that matter most to doctors and patients. Dan, what's so special about where we're sitting today?
We're sitting today in our our facility in Provo, Utah. This is, in many ways, the beating heart and soul of Dandy. This is the facility in which we manufacture virtually all of our fixed restorations, specifically crowns, bridges, and soon implants. Also, coincidentally, one of the finest marvels of engineering I've ever seen. Something I'm deeply, deeply proud of that we've been able to accomplish here at Dandy.
Can you tell us a bit more, maybe actually for the listeners who don't know who are you? Tell us about your role at Dandy and your role in building out Provo.
So I'm one of the co-founders here at Dandy. I've been with the company since its inception about 5 or 6 years ago. I spent a lot of my time on the product and the engineering side of the company. And I think Provo has been a real focus of mine of the company's for really for about 2 years now, 2.5 years now, two and a half years in the making. It's been obviously something that's involved the entire company. But insofar as Provo has required really deep engineering, really deep machine learning, really incredible robotics that I could, really nerd out about for hours. That's been something that I've been spending a lot of time on over the last couple of years to help make sure this is a reality.
Let me take a step back. A few years ago, and for a dentist who's listening who knows Dandy as a digital dental lab, a free scanner, what changed?
Well, when we first launched Dandy, I would say our core innovation, our core value prop was really helping bring really elegant and seamless scanning workflows to our practices. When you think about the life cycle of a crown, for example, the beginning of the life cycle is you have the patient intake and you have the clinician scan the patient's dentition. And then you have some sort of workflow that ensues that helps you attach the right information to that scan, like, what shade do you want, things like this. And then you send, and a workflow that then sends that scan off to a lab, right? And then of course the lab goes ahead and they design the crown, they make the crown, they show it back to you. In the beginning of Dandy, our core innovation was really more along how can we make that first part of the experience really incredible. Part of this was we built our own scanning software called Chairside that makes it super seamless and easy for anybody who's unfamiliar with scanning to pick it up, or for scanning veterans to have really efficient workflows. We pioneered certain workflows innovations like 2-appointment dentures. Again, like that's a customer-facing, doctor-facing workflow that helps you cut down on appointment time, the number of appointments to service a denture case. And so, but most of those innovations are like very directly doctor-facing workflows. Back then, we were not innovating on the manufacturing side. In fact, technically, when we first started the company, we weren't even a manufacturer ourselves. Many of our customers remember back in 2020 and 21, we would partner with other labs to help service the volume. But around 2023, there was a major ideological shift in the company where we realized that in order for us to deliver a truly exceptional customer experience, we had to fully vertically integrate the entire process end to end. And that's not just like, we got to do everything for the sake of doing everything. There was sort of a core realization that, when you think about the customer experience, the doctor experience, the patient experience of receiving that, that beautiful anterior case or that perfect drop-in fit posterior, you can't guarantee that experience just from having a really high quality workflow. You also have to have really high quality precision manufacturing. You need to complete that loop, or else there's no way we could guarantee at real scale that every customer has a great experience. And so around 2023, we expanded the aperture of our ambitions and we expanded the aperture of our investments to also include manufacturing and building extremely high quality precision manufacturing systems so that every crown we could deliver can be excellent.
So we have another site in Lehigh.
That's right.
And we vertically integrate the company in 2023.
Yep.
At what point during the scale up of Lehigh did you realize that we needed to think about the problem differently and actually move towards more of an engineering and manufacturing type style in the company?
Yes, that's a good point. So when we first launched manufacturing at Dandy, we approached it the same way I think every dental lab approaches manufacturing, dental crowns. We had rows and rows and rows of technicians. We had, rows and rows and rows of manually loaded and unloaded milling machines. We had the very typical, very manual dental lab system. Frankly, frankly, for some SKUs like partial dentures, it wasn't even digital. It was actually even for those a manual manufacturing process, or analog, I should say. And I would say that it was around the end of 2023, as the business was continuing to really scale. We thought about where do we want to be in a few years. And, our ambition as a company has always been we want to serve everybody. We want to be a dental lab that every dentist can rely on. We also want to be a dental lab that can service any custom-made restorative need that you have as a doctor, whether it be a simple posterior crown that just has to fit to a really complex, beautiful aesthetic case. Our vision has always been to serve all of those things. And we realized, I'd say around the end of 2023, that there was just no way, absolutely no way that your standard traditional dental lab operation was going to be able to service, the hundreds of thousands of dentists that we have in this world. There's no way I could start a single dental lab, run in the traditional way and serve them all and serve them with excellent, high quality reliability. The sheer number of technicians you need to hire to achieve that scale, besides the fact that that's a gargantuan hiring challenge, there's the even bigger problem that with that many different people, you have quality variation, you have all these sorts of things. And our doctors don't want quality variation. Right. Our doctors want the quality of our best technician every single time. Yeah. And so we thought to ourselves, how can we deliver the quality of our best technician every single time? And the answer was engineering. The answer was, how can we innovate and build a technology that can do something that has never been done before in the history of our industry?
When you come to that insight, was there a particular moment that led you to believe that it could be done in engineering? Because for, let's call it the better part of the last 150 years, restorations have been made by hand in the same way. So to take, what was the insight that said, I can apply technology now in a fundamentally different way than it has been applied before?
We did not know this was possible when we started building this. We did not even know this was possible halfway into building this. And I wouldn't even say we knew this was possible 90% into building this. I think it was only in the last 6 months, maybe 7 months, at which point this facility already existed, it was already being assembled. We were already starting to run some tests. I think it's only in the last 2 months that it really has become clear. It really became clear that this was possible. I mean, I can't tell you, it has been a 2.5 year process. Every month, there's a new, potentially unsolvable R&D problem, engineering problem, AI software thing that we got to build that is otherwise untenable, in the rest of the industry. And we maybe, because we have a different type of talent working on it, maybe could solve the problem that we do not know. But we did not know in advance that for most of these problems that they'd be solvable. And I, in this process, I've learned a lot of words I did not think I would know. Joe, have you ever heard the term high negative deviation?
I have not.
Well, you trust me, you don't want to know that word. The last thing you want is to know that word.
But I got enough other problems.
You got enough other problems. But we got dozens and dozens of problems that have, probably hundreds, but at least dozens and dozens of problems that have popped up throughout the build. Guys, we knew this was solvable. At one point, we had to shut down the factory for a week, early in build out, because we had bats How many business leaders in the world can say they've had their entire, like, all their plans and dreams and ambitions, like, delayed by bats?
Yeah.
There was a point in my life where my entire life was on pause because there was a bat in this building. Do you know how to get a bat out of a building this big? Because I sure don't. So putting this together is just a very, very challenging thing. A lot of things just went wrong that you never expect to go wrong. But I think it's because of the sheer determination and magnitude of talent that we have here at this company. Just the sheer fortitude of our engineers, the sheer talent of our operators allowed us to get through. I mean, it was really a team effort. I mean, hundreds of different people had to come together for this to work.
So we were on super tight timelines, and I actually don't remember the bat story.
I'm glad you were shielded from it.
Shielded. What did that actually do for the timelines here? What was the actual impact of that?
I think the bats delayed us by about 2 weeks.
2 weeks.
But like, this business lost millions of dollars because of bats.
We'll have to get good exterminators next time.
I think we got good exterminators.
So, Dan, you say this was a massive engineering challenge. Can you give me an example of the engineering challenge in delivering unprecedented quality and consistency at scale?
I think about this. This is more than a machine. This is like an ecosystem. It is all these different parts that have to work together. It's a delicate system, and it evolved. It took a long time to evolve this from all the individual parts. To give you a bit of a flavor of like an example of like how challenging the engineering has been. Our milling, we want to get hyper high quality milling.
Yeah,
hyper high quality milling. Most dental labs, there's like this process where you have a milling machine, you mill for a while, and then you have some sort of regular calibration schedule. You'll calibrate like once every week or something. I think actually at our old facility, we calibrate roughly once every week. This is fine, but it's not ideal because, it sort of implies that your mill may fall out of calibration at some point in that week. And it might be very subtle. Like for most labs, it's not something most labs would freak out about. You lose 1 or 2 or 3 microns or maybe 10 throughout the week, and then you get back to baseline when you calibrate at the end of the week. But we wanted to get to a place where there's really as little slippage as possible. And so we actually had to invent our own automatic calibration system inside the mills. Our mills now, what they actually do, I think is roughly once per day, is they'll actually feed in like a metallic, instead of feeding in a zirconia puck, they'll actually, once they feed in a metallic puck, and instead of using a normal burr, they're going to use like a metallic burr that's conductive. And they basically do this extremely complicated sort of automatic milling calibration thing once per day as part of their normal operation. So once again, not only do you get calibration more frequently than the average lab, but it's also automated, so it doesn't accrue to the cost structure of the unit, right? Without that, you end up with mills that will gradually fall out of calibration every week or so, and then you get them back into calibration. But getting them back into calibration, there's downtime, which costs money, and there's also the fact that you spent a couple of days out of calibration. Yeah. So that's an example where when you're aiming for if you're aiming for 50 micron precision, you don't have to worry about that as a lab. But if you're aiming for 1 to 5 micron precision, that stuff really matters.
So I'm a dentist or I'm a DSO executive working with many practices.
Yeah.
Why does that calibration actually matter? What tell me about milling accuracy.
It matters because it lowers remake rates. And I know DSOs and doctors care about remake rates because every remake is an extra appointment.
Yeah.
And every remake is frankly a slightly less satisfied patient. It impacts remake rates, and it also impacts your side adjustments. If you have an uncalibrated mill, where crown's 5 millimeters, if your crown's 5 millimeters too thin, that's a remake.
Yeah.
That sucks. If it's 5 millimeters too thick, maybe it's a remake, depending on how you manage your practice, or it could be a chair side adjustment. That's kind of annoying. You don't want to have to do that. We want to get to perfect drop-in fit every time. I know doctors care about a perfect drop-in fit, because who doesn't want a perfect drop-in fit?
When you think about the end-to-end line here, it sounds like there were dozens and dozens of engineering challenges that where the tolerances or the variance at each individual step in the ecosystem actually drive higher remake or longer inconsistent appointments for a dentist. I'd love to understand, how do you think, and how does Dandy therefore think about engineering those quality and consistencies to deliver lab products at scale?
A core part of our engineering philosophy with this lab has been how do we eliminate as much of the variance as possible. And frankly, a lot of the variance you get from most labs comes from the human elements. You have in most labs, you mill crowns out of a puck. Those crowns have to get singulated, right? You have to sprue, you have to like get those, you burr those screws off, right? There's typically tends to be some level of variance in terms of like whether or not the human does it perfectly right, or the technician does it like with a little bit too much there or a little too little. And that, depending on where the sprue is, can show up as a tight or loose contact.
Yeah.
Or can, God forbid, show up as like an aesthetic imperfection on an interior case. And so, when you look at this line, and there's not a single human on the line doing anything that could impact the quality of the unit. Not to mention, this line, it doesn't just have one QC station. It has like 3 QC stations. We aggressively QC every unit for color, for shape, for durability, for everything. And yeah, so the elimination of that level of like variance is a really core part of how we've engineered this line. 100%.
How does AI impact the floor and the operations here?
We're currently seeing, I think, some of the most exciting advancements in machine learning ever. One of the things that frankly is very interesting right now for a lot of companies, not just us, is, we're seeing all this innovation on the digital side of AI, but can we translate advancements in digital AI to something in the real world? This is why you're seeing a lot of like robotics companies get funded right now. So they're trying to realize this vision of, well, if you can do all this AI stuff digitally, can we like put that in a robot and have it do random things? The dental lab is actually a really exciting application of machine learning, but only if you can fully digitize the dental lab. Because, we already have this idea of like, you make a CAD design for every single case. Yep. That is custom for the case. And then you have, your traditional lab, brings that to life. But it's always been a bit of an incomplete system because, the CAD design's done by a human. Sure, you're milling with a milling machine, but it's off sometimes. And it's like painted by a human, So there's all these like automated digital components to it. What's really excited about this factory is, so now we've started to actually use AI to automatically generate designs for crowns. And that's not just shape, that's not just anatomy, that's also the characterization and the coloring of those crowns.
Interesting.
Right? We then feed that AI generated design. And, today, it goes through a human that verifies design, makes sure it's copacetic and looks good. But ultimately, it's an AI proposal. So we are getting better at being able to generate more consistent, high quality units every time. It enters the facility. And because of the way this facility is designed, we mill the crowns using a wax suspended process. So there's no human having to do the despruing. None of that. So it's in theory, a perfect rendition of the design. We then have an entire machine over there that scans the crown and makes sure it actually like adheres within like a very fine tolerance band to the milled design. And we actually even use AI at that station just to check and make sure it actually fits in the right way. Then we have a machine down there that can actually apply color basically at the micron level, like droplets of color at the micron level onto the surface of the crown, such that AI generated design, the characterization, the shade of the crown can be applied faithfully to the unit. And so what all this means is that the actual unit that comes out of this factory is more or less guaranteed to be an extremely faithful rendition of whatever, digital design it was that we generated and gave to the showed to the customer before it came here. I can invest, as an engineering leader, I can invest fully in our machine learning team, and we can just go super hardcore on building the best models that can just continuously self-improve. You just keep getting better as we get more and more scans, more and more designs, more and more cases, more and more doctor feedback mechanisms. Just all feed this like centralized brain that can generate cases. And I have a machine back here that can faithfully convert that brain's output to a real case that can go in your mouth.
Yeah.
That's the real exciting thing about this, is it basically, it takes this like really incredible thing that's happening in the digital world with AI, and it gives it like like a window or like an interface with which it can actually like enter into the real world.
One of the things you're talking about is, automating the end-to-end process for production.
Yeah.
And one of the things that we hear from dentists is, I want to speak to my lab technician.
Sure.
The ability to make adjustments to a crown are important.
Yeah.
How do you think about that type of relationship and interaction in the context of a digital product?
It's a phenomenal question. I'm really glad you asked that because something I've always believed is the lab business is fundamentally, it's a combination. It's, some businesses are just product businesses.
Yeah.
Some businesses are just service businesses. The lab business is definitely a hybrid of both. You are delivering a physical product, but without really high quality service, you're not going to deliver a great experience for dentists. And so I'm glad you asked that question. So here's the challenge you run into. So you want to give a dentist, a clinician, the ability to speak to a lab technician, which is like that's really important.
The number one most important thing.
Number one most important thing. You want to do it in a way that gives the dentist the most possible control. This is really important. You can have a dentist talk to a lab technician, but if that lab technician is not able to make the change the dentist wants, or if they are able to make the change, but it takes a long time and delays the case, or if they can go make the change, but the dentist can't really see the outcome until it arrives at their doorstep, those are all not ideal.
Yeah.
The beauty of a fully digital system, you can call your lab tech at Dandy, and you can say, hey, I want, I don't know, the prep for this case was a little bit awkward. Like I want to look at how you did the margin here, and I want to co-design that with you, or I want to see how you're thinking about the characterization to the incisal edge of this anterior. Like, let me tell you what I want, or let me show you a photo and walk you through my thinking. I would say an ideal workflow is not only are you able to talk to the lab tech, but the lab tech can also make the change while he's on the call with you and show you how he's making the change on the spot.
Yeah.
That is really only possible in a fully digital workflow. You can kind of approximate that with an analog workflow if you go in person to the lab, or if you happen to call the lab tech at the right point in time in the sequence of making the crown. You just happen to get that timing right. But the magic of a fully digital workflow is it actually doesn't even matter where the crown is in the process when you call. The crown could be literally in the packaging box. It could be all at the end of the process, already zipped up. And you call and you say, hey, I want to change the characterization of the incisal edge in this way. No problem. You go into the design, you fix the characterization in our designer, and you feed it back into this process. The crown gets remade in 10 to 20 hours. Boom, done. Back to the doctor. Or it could be that the crown has not even been made yet. It's not yet entered the facility, but it's completed design. Call the technician, make the same comment. They edit the design and they actually get it before it even enters the line. Same effect. You know what I mean? You can, or it could be in the middle. It could be literally any time during the process. You can talk to a technician that's on the floor. You can talk to a technician that's not on the floor. It doesn't really matter at that point because it's all represented digitally. And so, and then you can also, you can't really do this with an analog workflow. A digital workflow, you can actually see the technician make the change in front of your eyes. Please, accentuate the gradient transition from the middle portion to the incisal portion of this anterior, a middle third to the incisal third of this anterior. And then you can literally watch the technician with his slider slide that gradient. And you nope, stop right there. You don't get that level of control with an analog workflow.
And how do you think about it over the next, let's call it 5 years? Do you see that level and type of control being handed directly to doctors? Do you think doctors will eventually make those types of changes in the product?
I think doctors should always have access to a technician. Our DDP product has already been so popular. Digital design preview. As a doctor, you can, for any case, you can pull up the design of that case before it hits the lab. And you can rotate it. You can look at the margin. You can leave comments. That product, and it doesn't even have any editing abilities. It just has commenting abilities. It's already been so popular. You pop in some editing tools there. I'm sure some doctors really appreciate that level of fine, because some doctors really care about fine-grained control.
One of the main insights was around color, characterization, shade accuracy.
Yep.
Where did that insight come from? It sounds obvious, but maybe for the audience, what were the things that you heard from doctors that led you to believe that sort of the standard pre-shaded zirconia was not sufficient to deliver on the type of lab experience that we wanted to deliver.
I mean, you can tell partially by what they say. You can also tell by what they do.
Yeah.
For those like really high-end cases, we often see doctors will not want to send those cases to a large lab like a Glide Roller or Dandy historically. They often will want that like really close human touch, local lab feel for those really boutique aesthetic cases. And I think part of that comes from the manufacturing process. Part of that comes from the fact that when you historically, when you sent the case to Dandy, or when you send a case to most of these other large labs, you're getting like this like pre-shaded sort of zirconia situation without a ton of this like fine grained control and the characterization. That's just not optimal for these cases.
So a few months ago, we launched Polychromatic.
Yeah.
Which is effectively our high-end anterior offering.
It's nuts. It's absolutely nuts. I mean, the things I've heard from doctors on Polychromatic is crazy. I mean, people are looking at it like, wait, this isn't porcelain?
Yeah.
Sorry, this costs the same as monolithic zirconia, but it looks like porcelain. And it delivers fast. And also I can like see it digitally. That's crazy.
Last episode, we talked about Polychromatic and the advantages about it, but what actually goes on in the lab that allows us to deliver that?
Polychromatic has been the culmination of like a 2.5 year long, very complex R&D and engineering effort that has like spanned hundreds of people and at least 7 countries in terms of like where we had to go to find the right talent. The thing that enables it is we, unlike every other lab in the world, we have a machine in this factory that can actually, apply, take like a digital representation of the color that you want on your crown or the color pattern you want on the crown and apply it directly onto all the different surfaces of the crown. It's a really remarkable thing.
Well, how does shade get applied in a normal lab?
In most labs, you'll have like you'll have rows of dental technicians who will have like like a little mini paintbrush, and like a little mini color palette, and they'll take the crown, they'll like paint it on like this.
And we talked in microns earlier. Can you give me like a sense of what is the thickness of that brush? How does it apply? How accurate is it?
I mean, at that level, the minimum level of resolution you could realistically be operating at is like 100 microns, maybe 70. And with a human hair, 70 microns. I don't think your human technician is going to be able to like be looking at more subtle widths than the width of a human hair, resolution than the width of a human hair. So you're looking at like probably hundreds of microns of minimum resolution.
So the resolution for like a traditional hand-painted premium crown is 100 microns, the width of a small brush.
At least.
What's the resolution here?
Oh, it's not even close. We're probably operating at sub 5 micron.
Sub 5 micron.
Sub 5. Maybe at the micron level, actually. This is like the retina display of crowns. It's like a level of resolution you've just never seen before. But then once you see it, you're like, oh my God, how do I live without this? You know what I mean? Like, can you imagine using a computer today that doesn't have a retina display?
Yeah.
Like it's like you're needlessly assaulting your eyes.
Yeah.
And why would you do that to yourself?
When you think about what the impact of that, the retina display or the retina crown looks like, Polychromatic feels like for a patient or a dentist, tell me why a dentist should switch.
I mean, it's quite simply a higher clinical standard of care and a higher aesthetic standard of care. I mean, if you want to build your reputation as a premium doctor, as a premium provider, like you're going to want to be able to provide premium units. And I think, doctors don't need me to tell them, they already know this, but, I think traditionally there's been this implicit trade-off, like, in order to get that premium quality, you have to pay a little more for porcelain, right? Or what have you. But with Polychromatic, you can get porcelain level aesthetics, and you can get like incredibly high levels of control on the aesthetics of your units at no extra cost. It's like, why not?
No brainer.
Yeah, it's kind of like when we, gave away free scanners.
Perfect financial sense.
When we first gave away free scanners, our most common CX ticket was, is this a scam? Where's the catch? What's going on here? Now people are like, oh, if you're not giving me a free scanner, like, what are we doing here? Like it's so normalized.
Yeah.
But back then it was like this crazy thing. People couldn't wrap their heads around it all the time. Similarly, I'd say for Polychromatic, it's like I think people are starting asking like, what's the catch?
Yeah.
Why are you giving me, this like super high-end level quality at no extra cost.
Well, why not charge more for it?
We've very fortunately been able to do this in a way that does not increase our cost structure by that much. And so I think, we're very excited to pass on the fact that we're able to do this at a cheaper cost than like porcelain and other things to the customer. I think it's just good business.
Other businesses, other labs, they may not change their cost structure, but if they're delivering a superior product, we'll charge more for it. What's the philosophy that you and Tony have brought to Dandy?
The core thing that we want to do as a lab is we want to help doctors grade trade-offs.
Okay.
We want to be a no compromises lab. You can get units at mass market prices at craftsman level quality. That's what we want to be.
So the push here is always, and from your optimization, the way that you think as a founder, as co-CEO of Dandy, is break trade-offs for customers, align customer incentives to Dandy incentives.
Yeah.
And that forces us to engineer new ways of delivering product.
It's the crux of it, yes.
Yeah. When we first launched Provo, and to some extent Lehigh, we moved from shipping software into atoms, right? We went from shipping we went from bits to atoms.
Yeah, we went from bits to atoms.
What are the things that you learned along the way that was different than you expected?
I knew atoms were harder.
Yeah.
I didn't realize how much harder they were going to be. Atoms are really hard. To all the entrepreneurs, of tech companies that might be listening to this, I highly do not recommend going to atoms. Stick with bits.
Give an example of something that was super easy in software, but that actually turned out to be brutally hard on the floor here.
One of the very notable differences between atoms and bits is iteration speed.
Yeah.
With bits, you can, with software, you can launch a new feature, and within days, you can see if customers like it or don't like it.
Yeah.
And how they feel about it, and does it work, does it not work? It's very simple. For example, it took a lot of work, but at one point we actually launched an update to our byte alignment algorithm on one of our scanners. And within 3 days, we saw that it reduced byte alignment errors by 90%. Sick.
Yeah.
Clear answer, right? But with hardware, it's a little different. With hardware, particularly with manufacturing, we'll have a thesis, we're gonna make this change to improve the accuracy of the mills. And you don't really know if that change works for weeks, sometimes even months, to get back the remake data from customers, So it just takes longer to get answers to validate or invalidate hypotheses. And so it requires you, just as a leader and as a manager, to be a little bit more steadfast, I think, in your beliefs.
When you're
software, you can be a little bit more follow the data.
Yeah. Iteration speed in physical product and in hardware takes much longer. What are the leading signals? How are you learning from dentists to get faster feedback that allow you to remain steadfast or update your beliefs?
One of the biggest challenges, I would say, for any growing organization is how do you stay in touch with the customer as a leader? I think that's something I take extremely seriously. It's I think actually one of the existential problems of large organizations. I'd say one of the best things I think we've done is we've actually set up an advisory board of doctors and clinicians who I personally speak with on an extremely regular basis to get their feedback.
Yeah.
On a lot of these things. I shadow many, customer support calls. I shadow account manager calls. I spend a decent portion of my time. I have a decent portion of my time reserved for listening to and talking with customers. And we've really invested as a company, real-time energy and resources into building out an advisory board of folks, including, by the way, the advisory board is open to both Dandy and non-Dandy customers, just to make sure we're always in touch and understand how dentists are feeling and what they care about and how our product is or is not serving them well. It's really important to me.
And when you think about the iterations that we've made here, were there beliefs that you had or the engineering and product teams had that changed after getting feedback from customers?
In building our polychromatic system, we had really deep feedback sessions with dentists, and we were constantly, creating polychromatic crowns, manufacturing them, and then showing them to doctors to get their feedback, over and over and over again. And Now the feedback is like unanimously like insanely positive, but certainly there was a period of time where we were still fine tuning the system and we had to get a lot of feedback from doctors to really get to a good spot for sure.
You and Tony bet the company on building this lab, building all of this in-house. Yeah. It would have been far easier not to, and to continue to go and operate down the same model that we were operating as more of a traditional type dental lab.
Yeah.
Sitting here with all of the machines behind us, was it worth it?
Oh, for sure. I mean, I know earlier I was talking a lot about the problems with getting this thing stood up and the anxieties and the many, many times that it seemed like this would not work. And the many, many times it really seemed like this would not work. But it does work. I mean, we've done it. We've gotten to a place now where this is serving, I want to say, I think this facility is now manufacturing almost 100,000 crowns a month, and soon it'll be doing way more than that. And customers are really loving the frogging experience. And I know it was a lot of hard work to get here, but I'm confident at this point that there's a really incredible clinician and patient experience on the other side of all their hard work, and that for sure makes it worth it. And what also makes it worth it is the knowledge that if we had not done this, I'm quite confident this would not exist.
Knowing everything it took, what would you have done differently?
Yeah, I think we're a little bit late to bring on software engineers onto this project. We leaned in a lot, very heavy on the hardware early on, and we kind of brought in software. We probably could have shaved like a month or 2 months off of the timeline if we had, maybe a little more than that, if we had brought software in a little bit earlier. I also for sure would have installed bat nets. Day one. No, I'd say on the whole, I'm quite satisfied with how this came together. I mean, I wouldn't do too much differently.
And if we record this podcast in a year from now, what would you like to be, or what would you expect to be different when we record from the floor again?
It's a great question. I mean, for one thing, I think a year from now, we'll be doing a fair bit of this manufacturing out in Indianapolis at our new facility. So there might be a location change. Yeah. I also expect in a year it'll be much larger. I think behind us now we've got three or four lines up and running, but I think a year from now we should have way more than that. And I think we also are going to be taking a lot of the innovations that you're seeing back here for fixed and expanding that for removables as well.
Dan, thanks for the time and for opening up the lab to our listeners. If this conversation sparked anything for you on manufacturing, on where the dental lab industry is headed, physical manufacturing, AI, and robotics, find me on LinkedIn or drop a note to the show. That's it for today's episode of The Margin Line. I'm Joe Lynch, head of go-to-market at Dandy, and you can find us at meetdandy.com.